And in order to do this, you create a Docker file. It's a text file, and you will see examples later on that tells Docker basically how to build your software into an image, and what it should do when it starts, basically. And when you want to deploy your images, you push them to something called a registry. And then once that is, you want to deploy something on a cluster, and the images are then pulled from the registry. That's how it works. So that was Docker in a nutshell, and hopefully it will be a little bit clearer when we see some examples if you haven't seen it before. But the next question is then, so assume we have built an image that contains our fancy, shiny app or whatever it might be. And we have purchased a cluster of 3 beefy servers there. For instance, it could be also a very small one, of course. How do we then get our image to run on that cluster? And how do we kind of expose those services to the internet to get people to use our application? And that's where Kubernetes comes in. So it's a cluster management software that runs on the cluster and manages this. So what we will do, as I said, we will push the image to the registry. The second step is we will give instructions to Kubernetes. What do we want to deploy and how? Well, most of the how it can actually figure out itself. It's primarily what do we want to deploy. So what containers do we want to run? How do we want to combine containers into apps, basically, that are called pods in this terminology. Deployments are things that you can deploy. Services are something that someone can use. Load balancing services, how to scale, and that sort of thing. All those things we just describe declaratively to Kubernetes, and it will do the work for us. So that was the top level, how to do it. Now we're going to look at an example. So we're going to develop a Shiny app, and we're going to deploy it on the cloud, basically, with Docker and Kubernetes. There are a couple of steps to that. First, we need to develop it. Then we need to make sure it can run as a Docker container, and we'll want to test it locally to see that it works, it finds the dependencies and that sort of thing. Once we're happy, we will push it to a registry, and then we will tell Kubernetes we want to deploy something, and as a final step we will tell it to open this to the internet so people can actually use it. And I'm not going to do live demo. I could, because I have just done this, but in the interest of time I'll show you some slides, and if we get additional time at the end I will demonstrate some things. So this is the shortest Shiny app that I could think of. It contains a button. You can click randomize, and it will show a histogram that will re-render when you click randomize. So it's useless, but at least it's something. So, and don't worry if you don't understand the details. This is not important. So the new thing here, because I expect many of you have seen Shiny apps before, but the new thing here is the Docker file. So, and that, what you see in the blue box, is the actual Docker file that we use to package this. Nothing else is needed. And I'll talk you through this. So it contains a number of steps. The first line is always a from statement, and that means that this image, this Docker image, is going to depend on some other Docker image. And that's always the thing. And with that statement, you get everything that is in that other image, and you just build on top of that. And that's why my image can be really, really small, even though it contains an RStudio server and everything, and the operating system, etc. And then I specify a work directory, and that is just within the server, which is like a small computer. We need to put the files somewhere. I'm just specifying a directory where things are supposed to go. Copy ... is just copying all the files in our current directory into that work dir. So we are now copying files that we have built, such as our R code, for instance, into the container, and it will land in the working directory that we have specified. The next line is strictly not needed here, because that is default in the Shiny image we're building this from, but it tells Docker that this port, this network port, should be exposed to others outside. And if you don't expose the port, you have no way of getting network traffic in, so we need to do that. And 3838 is the default port for Shiny, so we'll use this in this case. The final line here, CMD, that tells Docker what to run when this container is started. So when we have built it, successfully deployed it, and it starts up as a container, what should it do? Should it do anything? Yes, it should run Shiny server, the script there. And that will start up Shiny server, and that will find our Shiny app, and it will start serving that as in this exactly the same way as if you were running it on your local machine. So with that Docker file and our app.r file, what we can do is to run a couple of commands. So if we put ourselves in that directory, we can just run docker build dot to specify the current directory. -t is to give this image a tag. It makes it easier for us to refer to it later on. And that command will build the image, and it will be stored in some internal directory on your system somewhere, but Docker knows how to find it. And in order to test this, we can run it locally, and we do that with docker run command. We need to specify that the port should be opened on our local machine as well. I mean, you could have something else running on 3838, and in that case you can specify some other port, so it just makes it easy. And then you specify the tag. This is what we want to run. And when that is running, we can just open a web browser to our local host and see that it's actually there. Once we are satisfied that that runs as it should, we can push it to the registry. So I can just write docker push and then the tag of my image. And in this case, Holgen / here means that this is going to target my repository at Docker Hub. So it knows where to put it, so to speak, but it will be pushed there. And in that case, we're done with the first two steps. We have written our app. We have actually 3 steps. We have built it as a Docker, and we have pushed it to the repository. So now we're actually done with the Docker part. Now we need to go into Kubernetes stuff. So we need to tell Kubernetes that we want to deploy this. And for that, we specify a deployment descriptor. And this is, again, a text file. It's in YAML format, which is, I'm not sure I really like it, but it's pretty condensed anyway. You could also do this with command line, just commands, but I like the files here because then I can check those into GitHub and manage them. This deployment tells Kubernetes we want to make a deployment. That is what it's called here. We will give it a name, My Shiny Deployment. In this case, we can tell it that we want to run 2 replicas of this, 2 instances of this. And this is a scaling dimension that is really nice. So we can automatically I could write 10 there and it will start up 10 instances. I might run out of memory, but that's how it works. We give the deployment a tag. We say this app is called My Shiny. And then we specify what container should I use to do this. And in this case, we'll use we need to specify the full URL of the image so that it knows I need to go to docker.io to get this. And the repository is called Holgen. The image is called My Shiny, and I want the latest version. So that's everything that Kubernetes needs to know to deploy this on the cluster. So this is kind of a minimal deployment descriptor, but there are many things that you can add when you want to configure more advanced stuff. For instance, you can add secrets that allow you to manage passwords and other secret things that you don't want to put in your Docker file or in your code. You can have Kubernetes pass that dynamically. You can define things such as persistent storage. So by default, when a container writes stuff to its local storage, when it's restarted, it's gone. It's not persistent in that sense. But you can specify in Kubernetes persistent volumes if you want the data that you generate to be stored somewhere. But the best practice and the normal way is just to send it away somewhere else, put it on a queue or something. You can also specify resource requirements, that it needs this much CPU to run, or it can maximum use this type of memory. So if it goes above that amount of memory, then it has probably have some memory leak or something, and Kubernetes will kill it. So a lot of things you can add into here, but this is a minimal example. So when we apply this, it's just a command to Kubernetes. Please deploy according to this file, and it will do it unless there's some problem in the file. and then it is deployed. But it's still not accessible because there's no networking way into that container, no way of accessing that with our web browsers. So that's the final step that we need to do. We need